Hello everyone, welcome to SQL Bits. I'm so excited that you are here and you're part of this. My name is Dustin Dorsey and this session is Baselining Performance with DEA. Thank you so much everyone for being a part of this session. I am so excited to be here. This is one of my favorite events of the year and actually my first time ever actually presenting at a SQL Bits. So it's been a little bit of a unique year, but as much as I was hoping to be there in person, I'm glad that we were able to work through things and I can be here with you today. This session is Baselining Performance with DEA. So DEA is the Database Experimentation Assistant if you're unfamiliar with it. So we're going to dive through what this tool is and what it does. A little bit about me. I am, if you can't tell by my accent, I am based out of the States. I'm currently Director of Data Management for a large healthcare organization in just outside of Nashville, Tennessee, Lifepoint Health. I do a lot of speaking engagements. I've been speaking now for a couple of years and done several events within that time frame. I do consider myself a little bit of a struggling blogger, and by struggling meaning just trying to find the time to be able to do it. And I am currently working on my first book with my wonderful friends, Kevin Klein and Dennis McDowell. So we will have a book coming out, hopefully here within the next 6 to 7 months or so. I'm also involved in some other different programs. I'm a friend of Redgate, Century One, Product Advisory Council, and I do help co-lead the Nashville SQL User Group and SQL Saturday. So try to be as involved in the community as I can. You've got all of my contact information available on there. If you have any questions following this or you want to link up and follow me, feel free to do that. Love to communicate with others. And again, any questions, please let me know. All right, so what are we here for today? So taking a look at the agenda, so what we're going to do is we're going to look at what the Database Experimentation System is, or DEA, as you'll hear me refer to it throughout the presentation, and the reasons of why you should use it. We will discuss how you use the tool, so how do you go through, how do you actually get it to work. We will look at how the tool has been simplified from some of the earlier versions of it and review what's new. So if you're brand new for the first time, you're going to learn some stuff, hopefully, and if you've never used this tool, we're going to take you from the beginning. And then the last thing is we're going to dig into the analysis reports that the tool produces, so where you really begin to find the value of what this tool provides. All right, who has used this tool before? So in this case, this is a pre-recorded session, and I do not have time traveler abilities, so I can't go into the future to see who's raising their hands here. But what I'm going to just make the assumption is that there's probably some people who are at least somewhat familiar with the tool who are watching this session, and then there's going to be some people who are brand new to it. So either or which you're in, hopefully you'll be able to get some information from this session that will be valuable to you and you'll be able to take back and apply to your everyday. Alright, so first, what is DEA? So maybe you've heard of this before, or you've seen it and you're not exactly sure what it is. Well, the DEA, it's a free A/B testing tool that Microsoft offers that allows you to evaluate differences in performance from a source and a target SQL server. It is a standalone tool that you can get from the Microsoft website. I've got it linked on there, but if you just search for download Database Experimentation Assistant, you're going to find it pretty quickly. But it is a Microsoft tool, and it is a A/B testing tool. What do I mean when I say A/B testing? So A/B testing has been around for a really long time, and there's a lot of different ways this can be utilized. But essentially what it means is it is the comparison of two versions of something that is identical except for an identifiable variation. So you're taking something that is in current state and you're adding a variation to it and you're seeing how it changes or how it affects things. So that is A/B testing. So within DEA, there are a few different components that make up this tool. So it is an A/B testing tool, so you are testing changes to see how they impact things. But there are three core components to this tool when you download it. There is a capture, a replay, and an analyze that make up this tool. These are going to make a lot more sense once we actually get into breaking down the workflow of the tool and understanding how to utilize it. But I want to go ahead and put this in your mind and just give you an idea of how this tool works. So by capture, what do I mean by capture? It's capturing a trace. So it's going through on whatever system you're running this on, it's capturing a trace from it that's capturing a workload. There's the replay functionality, which allows you to take that trace that's captured, be able to replay that on another server to be able to output a trace file on both the A server and a B server with a variance on there, and then being able to analyze those to determine what kind of differences have you had on it. So, but just want to break down some of the core components again as we go through this. These are hopefully going to make a little more sense as we start looking through the tool. By the way, I didn't mention this early on, but I will go ahead and share this. The first, maybe third of the presentation, we're going to go through slides, and then the back 2/3, we're actually going to dive into actually looking at the tool. So I'm going to share with you some information on the front end, and then we're going to go through and hammer that home when we actually get into looking at the tool. But just a little bit of insight into kind of how we're going to flow today. All right, use cases. So it is used to compare query performance, as we've talked about, and here are some examples of some scenarios of when you may want to use DEA. One of the primary goals of this tool, or use cases of this tool, if you will, is when you're upgrading to a new version of SQL Server, and you want to be able to test performance differences between your current version to the new version that you're going with. So we may all be familiar with, within SQL 2014, there was a new Cardinality Estimator that was introduced for the first time since the early days of SQL Server that changes the way some of our queries actually operate. So it's the query plans underneath and how those query plans are constructed have changed. And in some cases, or in most cases, we like to see that either stay the same or your queries get better. But there are cases where you can have degradation and performance as well going to those. And being able to catch those in the front end are going to be critical to making sure you have a successful upgrade. I remember early on when I was doing my first migration from SQL 2014, and I wasn't really familiar with the Cardinality Estimator, or at least the changes that they had made to it at that time, and we performed an upgrade, and we saw some code perform very, very poorly, that we actually had to revert back, fix it, and then move forward. This is a tool that would have helped us at that time to be able to capture what those queries would have been. Another use case here would be when you're migrating to new hardware. So if your sysadmins just went out and they purchased new storage, or they purchased new servers within your environment that are a little bit different build than what you're currently using, this tool can be utilized to determine what performance looks like on that new hardware. So you can create a baseline of what performance looks like on your existing hardware, which in this case would be your A server, and introduce that variance, so build your new server utilizing the new hardware, and then run the tool on there as well, and then be able to compare the performance between it. So it can tell you, set some expectations, or at least see if you're going to benefit or you're going to have degradation on the new hardware. Changes made to application code. You can introduce changes in application code and be able to track those. One caveat I would give to this is if it's executing like free code, like if you have an application and it just has the SQL within there, you're not going to be able to do that because this tool does use trace files. So when you capture the trace, you're going to need to be able to replay that trace. So if you're changing application code, you're going to want it to be stored within an object. So like a store procedure or within a view or something like that, where you're executing it but the code underneath, so within there. So it doesn't work for all application code changes, but again, if it's a store procedure or a view or even a function, you could make changes like that and test the performance differences on it. Making index changes. So if you're working on a critical system, you may not want to just go through and make an index change, or maybe you're dropping indexes or creating indexes or altering indexes. You may not want to do that on the critical system without really understanding what the impact of that index change is. So Database Experimentation Assistant can help you to be able to test out those index changes to see how it impacts code that's currently running. So index changes is another use case. Utilizing a new SQL feature. So in this case, I'm not necessarily talking about like new SQL features in terms of what's new within SQL Server 2019. I'm just talking about a new SQL feature that you may not be using today, but it could have existed for a long time. An example here would be you're looking at a system and you want to turn on page compression on the database. DEA is a great tool to be able to allow you to be able to compare performance before and after you enable page compression to see what kind of impact it has on your queries and your system that it's running. And then the last one is a use case is migrating to the cloud or to a different cloud service within your cloud provider. So this can be used if you're moving from an on-prem to a cloud solution, whether it be an Azure VM or Azure SQL DB or managed instance. You can compare performance between what you're getting today on your on-prem versus what you're getting in cloud. This can be really helpful in determining what sort of tier you need to be on to be able to figure out, okay, how can I get comparable performance to what I'm getting on-prem. You can also do it within the cloud, so if you're moving from, like, say, a managed instance to an Azure VM, you can be able to compare the performance between those two as well. This is a new feature. Previously, in the previous version of DEA, so if you've used it in an earlier version, being able to utilize this on anything outside of IaaS within the cloud wasn't possible. So just some things to know about DEA, just some things I want to share before we dive into it, and again I'll mention some of these a little later on when we're actually looking into the tool. First thing is know that this is a standalone tool, so it does have its own install file, it is its own exe, it is a standalone tool that you will use. It does capture workloads and replay them via trace files, or as recently introduced, extended events within this tool. Extended events, I guess, isn't new. It's been around since SQL 2012, but in the context of DEA, it is a new piece of functionality added. You will need, when you capture these traces, something to keep in mind, and this is one that I will mention a little bit later as well. You need around 30 executions of a workload of a query in a workload to be considered within the tool. So if you're executing a query and it's only executing a few times, the tool's not going to be able to go through and analyze the performance difference between those. It roughly needs about 30 executions of a query in a workload to be considered. There is built-in reporting to the standalone tool that allows you to compare the differences. So we're going to walk through that here shortly. And you will need a SQL instance to be used for creating the analysis. So there are servers that make up the A/B testing that you'll need, but once you get to the analysis, it does create a SQL database, but it can be on any instance that you want it to be. It doesn't have to be on one of the servers that you're using for your testing. You can put it anywhere you like. And then the last thing I will note is this is supported for SQL Server 2005 and later, so if you've got stuff as old as 2005 that's sitting out there, you can utilize this tool to be able to determine some of the performance difference on that. Alright, what is new in the tool? Well, first thing is, as I mentioned a moment ago, there is added support for extended events now. When the tool was first released, you were forced to use a profiler trace, but now you can take advantage of extended events. Obviously, if you're looking for anything pre-SQL 2012, then you're still going to need to utilize the trace functionality, but you can switch between those and use which one you prefer. They also added support for SQL Authentication. In the earlier version, the only option you had was Windows Authentication. That has changed, and you can use SQL Authentication now as well. A big thing, they added an inbuilt replay tool into the most recent release, which can be used for simpler workloads. So the way it replays traces is it uses the distributed replay tool, but within the newest version you can actually use an inbuilt replay tool, so you don't necessarily have to go through and configure a distributed replay and get all of that set up. They removed the dependencies of needing R, so you no longer have to install that. And then it added the ability to capture and replay on Azure SQL Database Managed Instance and SQL Server on Linux. So you can check those. And then there were some improvements made to the reporting on here. I mentioned a moment ago, I'll just call these out in the inbuilt replay versus the distributed replay. These are two options that exist for capturing and replay traces, but if you're looking at this and you're trying to figure out, okay, which one do I need to use? Do I need distributed replay or inbuilt replay? This might help you. Within distributed replay, The real advantage it gives you is it's the ability to replay a workload from multiple computers. So if you're trying to imitate a production workload and you're trying to execute and you want to be able to execute those across multiple computers, then you're going to need to use distributed replay when you're replaying those traces. The inbuilt replay, which is new, is a little bit more simpler option, but just note on that one you're only getting single computer execution. In the demos I'm going to show you today, just know that I'm only going to be using the inbuilt replay tool, but the distributed replay tool is an option for you. And then the analysis metrics. So once we get into the tool, again, we'll walk through this quite in depth. But the analysis metrics is really the benefit that the tool gives you, because it allows you to be able to take an output from a server A and a server B within there and be able to take the trace files from those and then determine what has changed between those. So if there is if there is a change in performance, if it's improved or degraded, to be able to take a look at those. It can also tell you, in the example of, I mentioned this tool is oftentimes used for SQL Server upgrades. It will show you things such as compatibility issues. So if you're upgrading from an earlier version of SQL to the latest version of SQL, it will tell you if there's compatibility issues or errors related to any of the code that runs in there, so you can get ahead of that. And it will share with you various details around workload comparison. Alright, so let's talk about the workflow real quick before we jump into the demo, so you can kind of understand kind of how this thing works. And you're going to find out as we go through this, the tool is a very simple tool to be able to use. There are a handful of little caveats or things to know, or you may bump your head a couple times. I know I did when I first started using this tool. But it's actually a fairly simple tool and what makes it up. So let's look at the workflow and the players. So what do I mean by the players? The components that make up this. So first thing is you've got the DEA application. So again, standalone tool that has to be installed somewhere. In my diagram here, I have it installed just on a separate computer. You could install this on like your server A. I mean, you could put it on the source. You could put it on server B. You could use a separate server altogether. But you will need somewhere to install the application. And the application can do what it needs against these servers as long as it has connectivity to be able to get to those. You do have a source server, so a lot of times when you're capturing your workload, you're going to want to do that against a production server because you want to capture a real workload, an actual workload that you're testing. So you've got your source server, which would be your production server. You've got your server A, which is you're going to want to build to match as closely as possible to your production server. So this is a separate server. You're not going to want to run the replay back on your production server. You're going to want to run that on a separate server. So you're going to create a server A that's going to mirror the source server as much as possible. So that means same hardware, same specs, same version of SQL. Everything is as identical as you can possibly get it. And then you've got server B, which is the same as prod, except for a single variance. So in this case, it could be, server A could be, and the source server could be SQL Server 2012, and your server B could be SQL Server 2019, and that is your variance. Your variance is a different version of SQL. But you're going to have a variance on that one. So what are the steps to be able to get this thing to actually work? Well, the first step is on your source server or your production server, you're going to want to take a backup of it, of whatever database that you're running this against. You have to do this first before you run anything else because that backup is going to need to be applied to your other servers. So the first step, take a backup of the source. Step 2 is using the DEA tool, you're going to capture a trace on the source server. So it's going to capture a workload for a variable amount of time that you set to capture a full workload, and it will save that out as either a trace file or an extended events file. Step 3, you're going to take the backup that you grabbed in step 1 and you're going to restore that backup to server A and B. Step 4 is you're going to replay that trace that you captured from the source on server A. So again, using the DEA tool, the functionality exists within there to replay that trace on server A. Step 5 is you're going to implement the variance on server B if you have not done so already. So in the example that we were talking about, if your production server is a SQL Server 2012 and you're going to SQL Server 2019, you're going to want to go ahead and make sure that your server B is on SQL Server 2019 before you complete the next step. Once you've completed the variance, then step 6 is you replay the trace on server B that was captured from the source. So again, the production trace that you captured, you're going to run that on server B. And then step 7, you're going to analyze the results using DEA. So DEA does have a built-in reporting component that exists within the tool that allows you to be able to point it to the two trace outputs from server A and server B to analyze the performance differences. All right, let's go ahead and let's jump into actually taking a look at this tool. All right, so for the purpose of today's demos, just because it's a little easier to build out, I've got everything built within Azure. Just note that this tool very much works on-prem versus within the cloud. You can use it on either or, but just for ease of being able to show this to you guys, I'm going to do it all from within Azure. So these are the components, if you on my screen here, that you can see that make up the different components that I'm going to be testing with. So you'll see I have a Destin Demo source server, so this would imitate what a production server would be. That is my source. I've got a server A and I've got a server B that I'm testing on. And I've also introduced some other different components in here, like we're going to do I'll show you an example of comparing performance between a VM versus an Azure SQL DB on here. But wanted to share with you, these are the different components that are going to make up what we're going to share today. Each one of these, I will mention the source server, server A and server B. These are using the exact same build of Azure VM. So it is a B2S build, and all three are utilizing the same build. So again, I want my server A to be as close to my production server as I can get it, and they're the exact same build on the Azure VM, and even using the same image, with the exception of the B one actually uses a little slightly different image because I'm using SQL Server 2019 on there. So most of what I'm going to show you today, I'm not going to bounce between the different VMs. I'm going to show you everything from server A, but just know that these others are players within this. So let me hop over onto my VM. One thing else I will note as well is for all of my testing, I'm using the Dunder Mifflin database. This was a database that was created by Tim Mitchell. So if you're anyone who's fans of The Office or so, it's kind of a fun little database to create things on. I did go into here and you'll see I've created various procedures within here that don't come with it. So if you were to go and download Tim Mitchell's copy, you won't find these procs in here. But if anyone's interested after this, just shoot me a message in the chat and I can share these out with you guys if you're wanting to get in here and play with this yourself. Alright, so we're going to use the Dunder Mifflin database. So what I did, and I'm not going to walk you through this, but I will just kind of briefly share this, is when I generated a workload, I fabricated a workload on here just to be able to showcase this tool. Again, I created those procedures that are on there, and then I used SQL query stress to generate a workload against that database when I captured the production workload to be able to get workloads from there. Each one of these procedures that existed in here, I ran them at least 30 times within the workload, so that way I would make sure that when I get in to be able to analyze the differences, those would be captured in there. Alright, so let's open up the tool. Alright. Hop on over here, and I'm going to open up DEA. So again, you can see that it is a standalone tool that exists within there. And when you first open up the tool, you'll see that there's really not a whole lot of options that exist within there. As I mentioned earlier when we were looking through the slides, you really have a capture, a replay, and an analyze that exists within there. So I'm going to walk you through these tools, and then we're going to dive in to actually analyze some of the traces that I've already ran comparisons on. So first thing you're going to have to do when you come in here is you're going to have to capture a trace. So just come in here, you hit capture, and it gives you the ability to be able to create your capture. So you would give this a name. We'll just call it test capture for the sake of this. You have a format, so I mentioned you can use a profile or trace, or you can use extended events. Anything post SQL 2012, it's probably going to be better to use extended events, but if you need to do something older, then profile or trace still exists there. You'll need to set the duration on here of how long do you want this to run against your production server. This is going to vary from person to person, because you're going to want to make sure you allocate enough time to be able to capture a sufficient workload. So I mentioned early on, one of the gotchas behind this was you really need around 30 executions of the tool for it to be able to be used by within the analysis that's produced. So you're going to want to think about that as you're looking at a workload to capture, of how often do these queries run, how long do I need to run to try to capture some of these queries to be able to analyze them. In my example, I only did 5 minutes, but for you, you may want to run this around 60 minutes, 30 minutes or so to be able to capture it during a peak time. You will need to define a location, so this could be local to whatever computer you're running DEA on, or if you're doing capturing a trace against one of the Azure PaaS services, so SQL DB or managed instance, you're going to need to use blob storage right here. It will not allow you to be able to save those directly on there. So you need to use a SaaS connection. And if you're not familiar with creating a SaaS to Azure Blob Storage, just a real quick look on this. If you open Azure Storage Explorer and you connect to your storage account, so I'm connected to my storage account here, and I have this one called Dustin Demo Storage, and you'll see that there's blob containers that I have created down here. To create a SaaS connection, you can right click on it, get shared access signature, and then you can go through here and specify it once you've given the permissions, and you just grab that URL from it to be able to create it. And you can set the time of how long does it have access to it, and those sorts of things, and what sort of permissions it has. I do recommend just going ahead and giving it full permissions when you create that SaaS connection, and then you can limit the amount of time that it would be able to use it. But what it's looking for is it's looking for this URL that is created right there. Or again, if you're doing just as I'm doing with these Azure VMs, you can use local storage for that. The next thing is you're going to have to put in your SQL Server connection details. So what type is it? Is it a SQL Server such as an on-prem SQL Server, an Azure VM, or is it an Azure SQL DB or managed instance? You'll need to specify those. And then your server name, what type of authentication you're going to be using, the database name, and then whether or not you want to encrypt the connection or trust server certificate. Once you have filled out all of this and you're satisfied with it, you can go ahead and hit the start button, and it will start capturing your trace as soon as you hit that button. It will bring up, I'm not going to go ahead and start one just because it takes time to be able to run, and we don't have a tremendous amount of time within this session. But once you hit the start button, it will bring up a screen that will show you how quickly it's progressing and a timer on it so you know when it is completed. And then the capture location is where the output of that trace will get stored. So when we get ready to move to the replay, remember where that location is, because you're going to need to go and get that file that was created. The next step within here is creating a replay. So this is going to replay a captured production workload. So what was captured within your capture is going to be replayed here. So we have two servers in this instance. I have a server A and a server B that I will need to run this replay against. I'll need to run it against both of them. Server A is a replica of my production server. So really it's going to be similar, should have similar performance on it that I have, or the same performance on it that I have on my production server, but server B is going to introduce the variance. So when I open this, you can see pretty self-explanatory options exist here. Again, you're going to need to give it a name, whatever you want your replay name to be called. You'll need to specify whether the source trace format was a profiler trace or extended events. You'll need to specify the location, so did you store it local or did you store it on a blob? And then put in the directory for it. This full path will be the full path, so you will need to include the file as part of that name. Then you'll need to specify what sort of replay tool that you want to use. As I mentioned earlier when we were going through the slides, there's two options that you can do here. You can use distributed replay, or you can use inbuilt. In my examples that I ran, I've only used the inbuilt tool. But again, if you're trying to imitate a production workload and you need to be able to execute that across multiple computers, you're going to want to use distributed replay. Again, there are a few things in there, like caveats and things that you need to do in terms of setting that up. So just check out the Database Experimentation Assistant documentation on Microsoft.com, and it walks you through setting up distributed replay if you're not familiar with that. There's also several folks within the community who have written blogs about going through and setting that up and doing that sort of thing. And then the last step is you're going to need to create a new location to store your replay trace. Again, if it is Azure SQL DB or managed instance, you're required to use blob storage. Or if you're using it, in this case on Azure VM, you can use local storage as well and just put a local path within there. You will need to check a box that says you have manually restored the databases, and I actually missed telling you guys that on the capture trace, but there is a box on the capture trace that says yes, you have backed up the database. So when we were looking through the steps, remember the first step is you take that backup, capture that trace, then you have to restore those databases over to your server A and server B. So this checkbox just says yes, I have manually restored those. And then again, you get the same connection details over here that you had when you did the capture that you'll need to specify. You will need to go through again on the replay, and you're going to need to run two replays. So you're going to have two trace outputs that are created as part of this, one for server A and one for server B, which is the variance. Once you have created those, once you have ran these, the capture, and here's my original capture that I ran against my imitation production server. I've also got several ones that I have ran otherwise. Alright, so when I open up my folder within here, I've got my actual production trace that was captured, but I've also got the outputs from when I replayed those. So my Dea Trace server A is my output from having replayed the trace on server A. You will notice that when you run a replay, you will notice two trace files within the folder. You'll notice a smaller one and a larger one. The smaller one is really just utilized by DEA as it's creating it and doing some of the internal work. The second one is the one that has all the output and the metrics and the data and stuff that you're going to use. So when we get into the analysis and you have to go through and you have to point them to the trace file from the output, you're going to want to pull the heavier one and point it to there. So that is my server A output, and then I've got my Dea Trace output, in which I've looked at it in various different ways. So I've introduced several variances within here where I've looked at it in terms of running on SQL Server 2019, running on different PaaS services, and even turning off server level options like turning off max stop, etc. So these are all the various, all the various outputs that I had from different tests that I've ran against this data to see how it performed. If I hop back to my tool here, we are now ready. If we've ran our replay on both our server A and server B, we're ready to start analyzing the data. So the first thing is you're going to want to come in here and you're going to need to connect. So I'm going to grab my server name from here because I'm using I just have a database stored on my local server, so just the server that I'm connected to here. Just note that when you do connect to this and you create new reports within here, it is going to create a database, an analysis database that is used. So just make sure whatever you're connecting through for your reports is a place that you don't mind if there's additional databases created. And also make sure whatever account that you're using right here does have sysadmin privileges. But it is going to create databases on there, and those databases will stay there until you go in and manually remove them. So let's go ahead and connect to this. So when I connect to this, you'll notice I already have several reports that are already created in here. I've got some related to SQL Server 2019. I've got one related to a SQL upgrade. I've got one with MaxDop off. I've compared it to various Azure SQL databases and Azure VMs, etc. So I've got different ways in here that I've looked at it. Just note, let me show you this, that if you create a new report, if you were to go in here and select it, you'll need to give it a name of whatever name you would like it to be, whatever server that you're connecting that to, and then the location for your trace file. So these are target 1 trace would be your server A trace of your original one, and then target 2 would be your storage location for server B, the one with the variance, and you'll need to specify what those are. You hit start and it will begin to do the analysis between those 2 trace files to produce these reports. So I'm not going to run through those. Instead, I'm going to show you some of the examples of some of the ones that I've already generated. Just note as well, when you do create a new report and you do add those in there, whatever the name you give it to, it will create them on your database. You'll see I have some in here called Analysis 100 DTU, Analysis 2 vCore. It will create databases behind the scene on whatever instance you specify to be able to do the analysis. Excuse me. So let's take a look at a SQL 2019. So I've used this example throughout the presentation of migrating from a SQL 2012 to a SQL 2019. So in the case of my servers here, my server A and my production server, which are identical, are SQL 2012, and the variance that I introduced was SQL Server 2019. So up here at the top, you can see my target 1 and my target 2. You can see where I had the extended events trace files stored, and you can see the product name. So you can clearly see this one was SQL 2012, and this one was SQL 2019. And then as I get down here and able to look into some of the details, I begin to be able to look at some of the performance differences between those two. So it does give me some pretty little charts right here that show me what level of queries degraded based on execution count or based on distinct queries, how many of them approved, how many of them couldn't be evaluated, or how many of those actually stayed the same. So I can begin to see, and based on the queries that I executed, those stored procedures on the Dunder Mifflin database, I can see that I actually have about 50% degradation going to SQL Server 2019 over what it was running on SQL Server 2012. I will note up at the top right here, you will see a threshold drop down that exists up there that determines, what is degraded versus what is improved. And this basically says if there's about a 5% difference, whether good or bad, then it's going to be degraded or improved. But if it's within that 5% variance, then it's going to say it's the same. And you can adjust this. I found 5% to kind of be pretty much on par with what I've been looking for. But you may only want to look for things that has a little bit higher variance to be able to see if there's a difference between those. You will also, if you look down here, you'll be able to see if there's any errors that were captured as along that. So some of those you may see like existing errors. There are some behind the scenes things that SQL Server is doing that may throw up here on errors when you're doing comparisons. Just especially if you're moving between different versions, or if you're comparing to like a PaaS offering within Azure, you may see some things like that just because it may not be available to you or available within that version. You can, all of these are you're able to dive into. So like within the existing errors, if you saw errors here, you could dive into it and look to see what query it was. But you can also see things like if there's new errors introduced, or if there are upgrade blockers that are part of this, you can dive into seeing what those are. So if I'm migrating from SQL 2012 to SQL 2019, I can come in here and be able to see if there was anything related to the upgrade itself where my queries would not run on the newer version or would prevent me from being able to upgrade. And then at the bottom, it will show you top queries in the workload, such as your top improved queries and how much it improved. Or you can look at top degraded queries, so the queries that had the most amount of degradation, and then be able to dive into those. But I'm going to hop back up here to these, and we're going to look at distinct queries by degraded. So when I click this, it drills me down into here, and I can see that there are several queries that exist up in here, and I have information on them in terms of duration. The duration in this case is going to be microseconds. So when you see those big numbers, just know that it is in microseconds. And I can pull, and from here I can dive into queries even further. So in this one, get list of products that need to be reordered, I can dive into the specific query and be able to look at performance differences between them. Now this one is categorized as a degraded, so I can dive into it and see some little more information about it. So as you can see, this query executed 80 times. That was the mean duration between those. But I also get some charts down here in which I can look at it as well. So on average duration, you can see how this query executed on average duration. So it was less. I can look at my CPU on the query to be able to tell, okay, how was my CPU from target 1 to target 2. And I can look at it in terms of average reads and average writes to see if it's doing more reads or less reads or more writes. I also have information in here around if there were any errors defined within the query, it would share with me information about them. And you can also, depending on the query, you can capture query plan information on it as well and be able to go in and look at how your query plan differs between them. I have noticed on the newer version though that I'm not getting query plans on this. It may be because of what I'm running that I'm not capturing that. But in the previous version, the way that this would show within here is it would show you a text query plan. So this would not be graphical. Instead, it would just be the text for the query plan to be able to use that. If I were to go back, again, I could dive through my degraded queries, but I could also go through and say, look at my improved queries. So this query here, get average age of existing employees, I could dive into here and I could see, how much better this query performed on SQL Server 2019 versus the previous. And I get the same amount of measures within here, error information, query plan information, in details about it. I can also, if I was wanting to move to an Azure SQL DB, I could also run in here and do comparisons between it. So in this case, I ran a comparison to look at performance between moving from my B2S virtual machine, which is a 2-core 4 gig of RAM virtual machine, to a 2 vCore Azure SQL DB to run the comparison between those. And as you can see, based on that comparison of running those, and again, you can see the product names up there of what you're looking at, that I had actually experienced degradation in performance by actually making this. So I would want to, if I was working in this in a real scenario, I would want to go through, understand why these queries are running less. Is it really a significant difference? As you can see here, the mean difference on at least some of these is fairly low. These top ones, like get top salesmen of Sabre printers or update customer's most recent sales date, those are about twice the time difference. So those may be something that I want to dig into a little bit more to understand why is this query performing so differently on SQL Server, on Azure SQL DB, or at least this version. Or maybe it's a situation where I need more resources on there, that a 2 vCore Azure SQL DB just doesn't compare to what I'm getting on a 2 vCore Azure SQL DVM. But I can compare those, and again, be able to look through them, see my top improved queries, top degraded queries, and be able to dive through and really begin to understand, okay, what is the difference between my workloads in this situation. Other things, I'm not going to have enough time to really dive through all of these, but I will show you one more. You can use this for on-prem to on-prem. You can use it from on-prem to cloud. There's a lot of different scenarios in which you can use this. In this example, what I actually did was I did a comparison on SQL Server 2012 with MaxStop set to default settings. So basically, MaxStop was set to 0, but the cost threshold was set to 5. On the first one, which is just the base out-of-the-box setup, and then I turned MaxStop off to see how it would perform. And as you can see here, it actually saw either the same or improved performance. In this case, these queries that I was running actually performed better with MaxStop off than on. Now, a lot of this is going to have to do with the cost threshold, though, because I mentioned that I just left it on the default settings when I was going through and running these comparisons. So the cost threshold was set to 5, so any query with a cost over 5 was using parallelism, and in some cases it was actually damaging performance on here. So I could go back through here, I could tweak, play with the cost threshold settings and the MaxStop settings, and probably find a place to where MaxStop is still running, but I've kind of found that sweet spot in terms of what I need to set it on to be able to maximize performance from my queries. But that is largely what the tool is. Again, the analysis is really kind of the payoff that you get in terms of being able to go through and be able to compare an A and a B target to be able to look through those. But again, you run the capture, you run the replay on 2 different servers to be able to capture those trace files, and then you use the analysis portion of the tool to be able to analyze the results between those and dive through those. Alright, we'll jump back over to the slide deck. We've got just a few more moments here, so let's talk about what we learned today. So a lot of information shared within a pretty short time frame here, but today we learned what the Database Experimentation Assistant is and the reasons why you should use it. So hopefully you've got a better understanding of the tool and you're beginning to think about different ways you can put this tool within action and use it within your current organization. We looked at how the tool works and how to start using it, so the different components that make up it. It is a very simple tool in that there's not a whole lot of components within it, so hopefully what I've showed you makes sense there. And then we've looked at the useful information and the insight that is gained from the analysis reports. So in the end, when you're capturing those, being able to utilize the tool to dive through the result sets to look what sort of performance impact did the variance that I introduced have an impact, or have impact. How much impact did it actually have? So that the analysis there gives you a lot of insight within to that to be able to make better decisions on there. Again, I appreciate you on joining my session today on baselining performance with DEA. I hope you've learned a lot. If you have questions or you want to talk about this more, or there's something that maybe I didn't cover within there, feel free to drop me a line in the questions on there, or using my contact information at the beginning. Feel free to reach out to me anytime, and I'm more than happy to have a conversation with you or to answer any questions you may have. Thank you very much, and hope you enjoy the rest of your SQL bits.